Assalamualaikum warahmatullahi wabarakatuh. Our group will present about video for digital.
For introduction, Verilog is a hardware description language (HDL). It is a language used for describing a digital system like a network, switch, or a microprocessor, or a memory, or a flip-flop. It means by using an HDL, we can describe any digital hardware at any level. Designs which are described in HDL are independent of technology, very easy for designing and debugging, and are normally more useful than schematic, particularly for large circuit. Verilog support a design at many levels of abstraction. The major three are behavior level, register transfer level, and gate level. Second, the design idea is implemented based on binary coded decimal (BCD) decoded to 7-segment display. By computing all the probability of multiplying 6 by 6 binary digits bit and grouping in table row, the obtaining of the combinational logic function is achieved by simplified the generate column of A5 ratio A0 using a Karnaugh map. Thirdly, full adder is a basic combinational circuit which is extensively used in many designs. They are the basic building blocks for all kinds of adder. A full adder adds 3 input bits to give out 2 output bits, sum and carry. A full adder can be implemented using 2 half adder and 1 2 input OR gate. A half adder add 2 input bits to give 1 sum and 1 carry output bit. Half adder have the following truth table and
For part 1, the question is design, simulate and verify a fully parallel 6x6 unsigned multiplier digital circuit with 1 bit full adder and half adder as building block. For methodology part 1, first we create a new project, then new source wizard to create a new source and click the Verilog module. Next, in this project we have 3 sub-modules. First module is half adder module, second module is full adder module, third module is multiplier 6x6 module. Then enter encoding and state encoding. Next, we construct the Verilog test picture as the next step. Then change the encoding input, then click behavior, check syntax to imitate coding. And lastly, the final is we enter the input A and B and run the program.
So for the simulation part 1, this is the design for the 6x6 multiplier. We have A and B as the input 6x6, and P0 and until P11 is the output for the multiplier. This is the first module for the circuit for half adder. We name the module is HA for half adder. The port is sum, Cout, A and B. So we declare the input is A and B and output is sum and Cout. After that, we use the subshell command to assign the gate SO for N1, and the output is sum and input is A and B. For gate N, we name the N2 and the output is Cout and input is A and N as the input. Output is sum and Cout. So we declare the wire for N1, N2, N3 and N4. So after that, we assign the gate for SO with the output is N1 and input is A and B. For the next SO is sum for output and input is N1 and Cin. The third gate is N. Is the output is N1, input is A and B. So for the fourth gate is N, output is N1 and input is B and Cin. Next is the N gate. The output is N3 and input is A and Cin. So the last gate is gate OR. The output is Cout and input is N1, N2 and N4, and we end the coding. Okay, for the multiplier module 6x6, the port is P, A and B. So for the input A, the bit is 6 bit, 0 until 5, and the other is B for the input. output, we declare the P, and the bit is 0 until 11. So this is the coding for the multiplier 6 by 6. We use the structural command to design this coding. Okay, for the last module is the test module for multiplier 6 by 6. And then the input is A and B, the output is B. So for the initial design, we use the 6-bit input, 1111 and 1111. So for B, we use 6-bit. The input is 0000 and 0001. So we run the for the simulation. This is the output for the simulation. So for the third layer and the second layer is the input for A and B that we use. So we get the output is uh, 12 bit from P0 is the LSB, P11 is the MSB. So we get the output is 0 and 1 1 1. So this is the final output.
The question asks to design, simulate, and verify a synchronous digital system that detect and recognize your student ID as password that can be used to generate an output signal. The student ID is entered to the system sequentially and synchronized to the master clock for proper operation of the system. The system is expected to generate an output logic height for 3 clock cycles if the ID sequence is detected correctly. The system will then return to the wait state where it waits for a new sequence to be entered by user. Use any of the student ID from the group member in this design. For methodology part 2, first we create a new project. Next, new source visit to create a new source and click Verilog module. Then we use Lilith machine to conduct this project. Then the input we use is 100. Then we design a Verilog test feature. Next, we assume time in second as 3 clock cycle. And lastly, after input 100 enter, the output logic height for 3 clock cycle.
Okay, for the simulation part 2, we use Billy for FSM machine, which is S0, the output is 0, and S1, the output is 1. Okay, for question 2, we set up the module, which is our module name is Simon 2. The input is clock, reset, and X, and the output is register A. Next, we do the register state and next state, and the parameter is S0, which is output is equal to 0, and S1 is equal to 1. So, if reset state is less than equal to S0, so we started with S0. Then else state is less than equal to next state. And then always at state or X, we begin the case state S0 if input is 1. From S0, input is 1, we go to S1, which is output equal to 1. Else, if input is 0, the output is 0, and the next state is S0. So for case S1, if input is 1, the next state is equal to S0, and the output is 0. And if we input X is 0, the next state is S1, and the output is still 1. So if default, the next state we direct to the S0, and then we end the case and end the module. For the test bench file, we need to register the clock, register reset, and also the X, and wire A is the output. And then for unit under test, we declare it clock, reset, X, and also A. Then initial begin, clock is starting with 0. So for the first clock, it starts with 0. And then always hashtag 10 clock equal to not clock. So that means the clock will move every 10 nanosecond. Then we start to code the condition, which is 3 high clock cycle. At first, initial begin, reset equal to 1. Then we delay 10 nanosecond. Then the reset will be equal to 0. And then for the first positive edge clock cycle, when the input is 1, it start from S0. When we input 1, it will go to the S1, which is output equal to 1. And then for the next positive edge clock, we put 0, which is it also still at S1, and the output is also 1. The next condition is we input another 0, and it will remain in the S1, and the output still go back to S0, so the output will become 0. So that's why we input the X equal to 1. It will go back to S0, which is output is equal to 0. And then we put an input equal to 0, which is it will be in the S0, and it's looping answer 00 till we end the module. Okay, from the waveform, we can see that first the reset is equal to 1, and then after 10 nanosecond it will become 0. So from the first one, we don't care about the input value, and then we input the input is equal to 1, which is they go to the S1, the output will become 1 for the first clock cycle. And then condition 2, we input 0 at the positive edge clock, and the output will remain to S1, which is 1. And then we input another 0, and it's still looping at the S1, which is we get 3 high clock cycle. And then we need to put value 1 so that it can go back to the S0 state, which is the output is equal to 0. And then we input 0 so that it's looping into the S0 state, so that the output will remain 0, 3 high clock cycle, which is what the question needed.
For conclusion for this assignment, uh, we we analyze the series and parallel multiplier, the type of storage device, data loading and data retrieval occur at the same time, parallel input, output, and clock signal. Next, we also analyze the Zillion Project Navigator, use Verilog and VHDL as programming language, suitable for beginners, can understand what have been learned in class. That's all from our group. Thank you.